Lesson 6.6, the remainder and factor theorems. Synthetic substitution can be defined as using synthetic division, to evaluate a function. So the remainder theorem basically says if a polynomial p of x is divided by x minus r, the remainder is a constant p of r, and p of x equals q of x times x minus r plus p of r, where q of x is a polynomial with degree 1 less than p of x. So an example would be x squared plus 6x plus 2 equals x minus 4 times x plus 10 plus the remainder of 42. Well, that's a whole lot of words to just tell you about a process that can be used. And so in example 1, we're going to use the process of synthetic substitution. Before, when we had f of x equals 2x to the 4th minus 5x squared plus 8x minus 7, and we were supposed to find f of 6, we would just plug a 6 into all the x's. Well, now we can use some synthetic substitution to find the same answer that we could find by plugging it into the x's. And you may wonder, why do we have to find it in a different way now? But since synthetic substitution is really going to help us figure out how to find other things, so it's worth learning how to do. But synthetic division, most of y'all like it. It's not really too hard. You do need to remember to put your zeros in whenever something's missing, and you have an x to the 4th, an x squared, an x, and then just a number without an x. So I had to put a 0 in for my x cubed because it's missing. And so I'm going to bring this down, and that gives me 2. 6 times 2 is 12. 0 plus 12 is 12. 6 times 12 is 72. 72 minus 5 is going to be 67. Oh, brother. And 6 times 67 is, and then 6 times 67 is 402. 402 plus 8 is 410. 410 times 6 is 2460. Minus 7 is 2453. So this number that's your remainder is what f of 6 equals. If I did regular substitution, I'd get 2453 if I did it correctly. Okay. So basically it says the remainder theorem tells us that this equals 2453 when I plug a 6 in it. So let's check your progress. Let's look at another example. We are going to do synthetic substitution, and we're going to plug in a 3 because this says find f of 3. And I'm going to use a 2, a negative 3, a 0 because there's no x, and a 7. So my 2 will come down, and I'll get 6. Negative 3 plus 6 is 3. 3 times 3 is 9. 0 times 9, or plus 9 is 9. 3 times 9 is 27. So this is going to give me 34. So now I know f of 3, if it were plugged in to that function, would be 34. So let's look. A depressed polynomial. Depressed polynomial has a degree. That is 1 less than the original polynomial. So the factor theorem says this. The binomial x minus r is a factor of the polynomial p of x if and only if p of r equals 0. In other words, the remainder equals 0. So we're going to look at example 3 and determine whether, it says determine whether x minus 3 is a factor of x cubed plus 4x squared minus 15x minus 18. Then find the remaining factors of the polynomial. So we're going to actually factor this, and we're not used to doing that. And the way we're going to do that is use synthetic substitution or synthetic division to do it. So when I'm looking to see if this is a factor, I'm going to put a 3 in my synthetic division. And I'm going to put in the numbers that belong here because of the polynomial. And I'm going to do synthetic division. So 3 times 1 is 3, which is 7. 7 times 3 is 21, and that would be 6. And 3 times 6 is 18. Negative 18 plus 18 is 0. So now I have a remainder of 0, which means x minus 3 is a factor of this polynomial. Well, now this 1, 7, and 6 give me the depressed polynomial, which is 1 less than the original polynomial. So it's a degree, 1 degree less than. And so it's going to be x squared plus 7x plus 6. So to find the remaining factors of the polynomial, I'm going to actually just factor this with product sum. Because whenever you have a quadratic, you can do that. And my product is 6 and my sum is 7. So 6 times 1 will give me 6, and 6 plus 1 gives me 7. So I actually will have the factors of x plus 1 and x plus 6. Now, these are the remaining factors, and we answered the question that this is also a factor. So if I had to factor that polynomial, I would get x minus 3, x plus 1, and x plus 6. Okay, so let's go on down and look at the next one. Get another example. It's a check your progress, but I want us to work that together. So check your progress here means that I'm going to determine whether this x plus 2 is a factor. And so I'm going to plug in a negative 2 right here so I can do synthetic division. And I have 1, 8, 17, and 10. So I drop the 1, and 1 times negative 2 is negative 2. 8 minus 2 is 6. Negative 2 times 6 is negative 12. 17 minus 12 is 5. And negative 2 times 5 is negative 10. So I get a 0 remainder, which means this is a factor of that polynomial. So now this 1, 6, and 5 will be a depressed polynomial. And I started out originally with an x to the third graph or function. This is going to give me 1 less. So x squared plus 6x plus 5 is my depressed polynomial. Now that it's a quadratic, I can use product sum to find the remaining factors. And so I'm going to use the product of 5 and the sum of 6. And I will put in parentheses those two factors. Two numbers that multiply to give me 5 would just be 1 and 5. That's all there is. And 1 plus 5 will give me 6. So that works. So I'm going to have x plus 1 and x plus 5. So those are my remaining factors. So if I wanted to say what this polynomial factors into, it would be x plus 2, x plus 1, and x plus 5. So you're going to have a worksheet tomorrow to work on during class, and you will need these notes and examples just to figure that out, to be able to look at them and figure them out together. So make sure you take the time to work on these as much as possible, and then Monday we'll look over them again.